Hello and welcome to another episode of Digital Marketing Answered. We're here today to talk about the fundamentals of AI, how it works and why it's important to understand it. And I'm joined today by Professor Paul Watson, who is Director of UK's National Innovation Centre for Data and has been a Professor of Computer Science at the Newcastle University for over 20 years. He also directs the EPSRC Centre for Doctoral Training in Cloud Computing for Big Data. And after an MSc and a PhD at Manchester University, he began his career there as a lecturer before moving into industry for ICL to design parallel database servers. Then in 1995, he joined Newcastle University, where his research and teaching focused on scalable data engineering. He also directed the UKRI Social Inclusion for the Digital Economy Hub that tackled social exclusion by designing digital technologies to help people and communities. Professor Watson is also a Fellow of the Royal Academy of Engineering, a Fellow of the British Computer Society, a Chartered Engineer, and he received the 2014 Microsoft Jim Gray eScience Award. So a very warm welcome to you, Professor Watson.
Thanks, Tim. It's good to be here.
That is quite a CV that I've just got through there. To start with, it'd be really great to understand a little bit for everybody to your professional journey as to what you've done to bring us here today.
Yes, well, after my PhD, I got a job as a lecturer at Manchester University. And this was in the time of the second big AI boom. And so we were working on a new sort of machine to support AI applications. And we got the interest of what was then a local company, ICL, who some of you may remember. They were a 20,000 person British computer company at the time. And they decided that they would like to take our research prototype and turn it into a product. And they asked me would I like to go across. So I thought this was a fantastic once in a career opportunity to see something from a few boxes and lines on a blackboard, as we had it in those days, through to a soldered up jerry built prototype right through to a product. So I accepted, and I had 5 really good years in ICL, and we built the product and sold it around the world. And then I decided I wanted to move back to academia in order to design the next generation of such machines. And so I moved back to Newcastle University, and here I am.
Wow. Okay. So you are, or you have been for many years actually, at the forefront of AI, machine learning. We asked you to come on Digital Marketing Arts today because I think that it's important as marketeers. There's a real rush to embrace this technology, but there's often not a lot of conversation around the fundamentals of this technology. So can we start off with maybe a little bit about the core of AI and description of machine learning, and so just help people understand what sits at the bottom of all of this fantastic jazzy new stuff that marketeers are getting into.
Sure. Well, if you look back at the history of AI, then it really goes back to 1948, when the very first modern computer was built at Manchester University. And people like Alan Turing started to get interested in how we could write software that would be able to do what humans could do. And so there's been a 70-year journey since then. Turing thought that the problem would be cracked in 50 years, but we're 24 years beyond that now, so we haven't made it yet. But over this time, various different technologies have come and gone as being the thing that most people thought would deliver artificial intelligence. And it got to the point about 15 years ago where really AI was in the doldrums. Really, there was very little investment by industry, little interest in research. But what happened was that mainly a group at University of Toronto, led by Professor Jeff Hinton, who's become very well known for his work now, came up with a new sort of neural network. So neural networks have been around for decades. And this is the idea that perhaps we could build AI systems by mimicking the way the brain works. So as you know, the brain has a set of neurons that are connected together. It's got an awful lot of them. And originally people tried to implement these in software, and we could only work with a few tens of them because computers at the time weren't very powerful. But now people are building these things called neural networks, which simulate the way that neurons work in a very high level way. But basically, you've got a set of these neurons in software, and they're connected to each other in layers. And what happens is that you start with some input. So let's say we're trying to classify an image. So let's say we're trying to build an autonomous vehicle for Elon Musk or somebody. So we're driving around in a car and there's a camera pointing out of the windscreen. And what we want to do is to be able to identify what objects we can see. So the image from the camera would come into the first layer of this neural network. As you know, the way images are represented in computers is a grid of numbers, pixels. So the numbers would flow into the first layer of this network, and the neurons would take in inputs from the image, and then they would apply a mathematical function and then send a number that they would produce through that function out to every neuron in the next layer. And every neuron in the next layer does the same thing. It takes in all of the numbers that are coming from the first layer, applies some mathematical function that generates another number, and that goes out to the next layer, and so on. Eventually, after lots of layers, you get to the end of the network, and what that has is very specialist neurons. And what these do is that you would say have one, if for this example, you might have one which is the car neuron, you might have another one which is the lorry neuron, another one which is the road sign neuron. And what the idea is that when you show an image with a car in it, so there's a car in front of you as you're driving, then you would want the car neuron to produce a high number, and all the other neurons, like the lorry neuron, to produce low numbers. And so that's how the system would say, this is a car. Now, what's clever about that is that the way in which it does this is because as the numbers flow along these connections, they are multiplied up or down by what we call weights. So it's not just that the number just passes uninterrupted from one neuron to another, it gets magnified or reduced. And what machine learning is a method, an automatic method, to set these weights in order to achieve some goal. In this case, to classify these objects. And this happens completely automatically.
Wow, okay. So you've just described the fundamentals then of machine learning, is that correct in terms of?
That's right. That's the process of setting the values of these weights. And so the way in which it does that, I've said it happens automatically. So how does it do it? Well, what we do is we give the machine learning algorithm lots of examples. So we'd give it lots of images of cars, lots of images of lorries, lots of images of road signs, and each one we would have classified already. So a human would have said, this image, this is a car, this image, this is a road sign. And so in this way, the system knows what each image is, and it optimizes it, it adjusts the values of these weights so that overall, if you give it an image of a car, the car neuron lights up. If you give it an image of a road sign, the road sign neuron lights up.
Right. So this is one of the core things that a lot of people have started talking about, which is the training of the AI models. What it learns from then has a bearing. So that's a very good model to understand in terms of like the car thing, because we can all sort of relate to autonomous driving technology being developed. But with the expanse of these other generative AI tools, where's this learning coming from?
Yeah, so learning is the key thing, and this is why there's been this big boost in AI. And the reason is there's lots of data out there now. 20, 30 years ago, we couldn't have done this because we didn't have very much data. But now, for example, to train up systems to identify objects, what big companies can do is they can scrape all sorts of images from the web, which have already been classified by humans, because humans tend to write captions underneath which say what's in the image. So, and
Right.
we might have hundreds of thousands of these for the driving example, and that's what we use in order to do the training.
So so the development actually has been not just the idea of the layered neural networks that came from developments in Toronto, but actually the availability of the data then to train the models.
Exactly, that's been very important. And the third part of this is the availability of sufficiently powerful computers which accelerate the process of machine learning. It can still take a very long time. We might come into large language models later in generative AI,
Yeah.
but for those, it can take several weeks to train one of these neural networks, and it costs several $1 million in order to do that. And the way it's doing it is these companies have vast servers, lots of different servers that are all working together in parallel on different parts of the problem, and they're using very specialist sorts of accelerators. In fact, interestingly, the accelerators that they tend to use are GPUs, which first came around for gaming. So if you wanted to do gaming, play some first-person shooter or whatever, and you wanted to look smooth, then you'd buy
Yeah.
a GPU, a graphic processing unit for your server, and plug it in.
Yeah.
And over the course of the last 10, 15 years, people have realized you can actually use these in order to accelerate machine learning. So you're right, it's not just the machine learning algorithm that came in at the same time as the availability of vast amounts of data and also these faster computers.
Wow. Okay. Yeah, and I'm glad you mentioned the large language models, because I think a lot of marketing leaders are using them. Their teams are using them. So could you explain to us marketeers, what is a large language model like ChatGPT?
Yeah, sure. So I think before I start, it's important to realize that there's a lot of good things people do with machine learning, which doesn't involve large language models. So, that's been
Okay.
machine learning's been the most successful part of the current boom in AI. And large language models over the last 2 years have generated a lot of interest, but there's an awful lot of work going on that doesn't use large language models. But I'll tell you something about large language models. So,
Okay.
so they're a form of neural network, but they're absolutely enormous. So you can have tens of billions of these neurons that I mentioned earlier, and they can be trained for something like ChatGPT 3 that is trained on text. And so you can have many billions of lines of text which have been scraped from the web, come from collections of books and documents. And these are used as the training material in the same way I've described for machine learning. But what you do to train a large language model is you're actually training it for next word prediction in a very clever sort of way. So if you've got just got my phone here, but
Yeah.
anybody who's used who's sent text messages on a phone will know that as you start typing, then on my phone I get 3 words that appear above where I'm typing, and I can click one of them. And that's because the system, it isn't a large language model, it's quite simple. But what it's doing is suggesting what's the most likely word you want to type. And so to speed things up, you can just click on it and it chooses it. Large language models are a twist on next word prediction. So what they do is, first of all, they're predicting the next word based on a very long set of text that you give it. So as you know, if you use ChatGPT 3, you can give it whole documents, you can type whole paragraphs in. And so the next word it's suggesting is based not just on the previous word, as the previous couple of words, as happens with a phone, but on all of this, could be up to thousands of words of text. And that makes it more likely to suggest something which is relevant and in the same style as the previous text. The other thing that it does, which is a blessing and a curse for it, is that to make things more interesting in the output, what it does is it doesn't just suggest, predict the most likely next word. What it does is it picks a set of words which might be likely based on all of the documents that it's been taught on, and then it randomly picks one of those. And then once it's picked one word, then that word and all the previous words are then used to predict the next word and so on. So because it's slightly random, this is where we get behavior which looks to us to be creative, because it's not going along the path we might expect. It goes off a bit of a tangent sometimes, and then it keeps going, and away it goes. So that's why quite often we ask it to do something and we think, gosh, that's really creative, the sort of thing a creative human might have produced.
Yeah.
But the problem with that, of course, is this thing that's called hallucination,
Yeah.
where it can come up with text, and I'm sure anybody who's tried it will have discovered this, come up with text which really doesn't make sense. It might be very convincing, but it doesn't actually make sense when an expert human looks at it.
Could you give a couple of examples of hallucinations that maybe you've seen that will help people understand the what could happen there?
Yeah, so there's been a few examples that have caused companies some problems. So I won't name the companies in case any lawyers watching your podcasting, but one of them is a large American company which what they do is they sell services based on legal information. So they ingest lots of legal cases. And for years, what you can do is you can type in some keywords, a bit like you would do to a search engine, and it would give you cases that were relevant to those keywords. And then it would give you a link to the case. So you click on it and go to the electronic version of the law book, which talked about that case. So if you're a lawyer, as you know, you're interested in precedent, can you find another case which is analogous to this one? So you can tell the judge, look, in this case, the defendant was not guilty, therefore in our case the same thing should happen. So it's been used for that for years. And what they decided to do was to bring it up to date using AI. So they built a system using large language models. So the large language models I've talked about, like Chat GPT 3, as I say, they're trained on what's on the internet and what's in a corpus of books that they have access to. What you can do is you can train specialist large language models on your own data. So you can choose the data that they're trained on. And the idea is it gives you more accurate, more better results from the questions that you ask. So this is what they hope for. But when you looked at, somebody sent a screenshot of what they'd done. They asked for some information about a particular case by using keywords. And the first paragraph was excellent. It's exactly what you want. It was a nice, concise summary of a case with a link to the details of the case. And then the second paragraph started to introduce some other cases that they thought were less relevant, but still might be taken into accord when you were presenting your case. But the first one said, as Judge such and such stated in 2025 in case such and such, and then there's one below that said as in case such and such in 2027. So it's actually making up cases in the future. Right. And this was an example of hallucination.
Yeah. Wow. And that's really clear in terms of the problems that it can generate, because when you talk about, say, ChatGPT as being trained on the content of the internet, it's not a search engine, is it? It's something very fundamentally different.
Yes, that's right. It's not trying to find some text that's already out there with the keywords in that you give it. It's trying to generate text that's based on the starting text that you type into ChatGPT 3 using this repeated finding of the next word and then finding of the next word after that, and so on. So it's not copying something, it's generating something from scratch. And sometimes, because of the way in which the data has been ingested, then it will be very close or identical to something that's already out there. But other times it's new and completely different. And as I say, not always truthful or accurate.
Yeah. So you have to assume that it's just words. It's not giving you data. Would that be a safe assumption to say?
Yeah, it doesn't understand what it's producing, and nor is it reproducing something that an expert human has generated. It's an algorithm for generating new text. So with like everything that I'm very impressed with large language models for some applications. I find it great when to solve the empty page problem. I have to
Yeah.
write something. I bring up Word. There's a blank document. What do you do to get started? Well, usually you go and make a cup of tea or something, or tidy your
Yeah.
desk or whatever. It's quite often hard to get going. But if you can just type in something into one of these large language models to get a start point, and then it gives you something to edit and something to think about. It may have ideas that you haven't come across. So it's good for things like that. But the
Yeah.
idea there is that there's an expert human
Yeah.
who is using that as an assistant. It's not replacing the human and doing something on its own. And I think that where we've seen, as in the case of that the legal information system, where we've seen that
Yeah.
things go wrong, it's because there's not an expert human who's looking at what comes out of it and deciding whether or not that's fit for purpose.
Right. Okay. Okay. So that's, yeah, it's clear that it's an assistant to a human, not a replacement for a human. Okay.
Yes.
Just on the learning, there's been some cases where people have talked about bias and model bias, and the problems also with being overly cautious or not biased. Can you explain how bias is getting into models in different ways, but also how people should learn to, identify it, and then maybe what they can do about it?
Yeah, sure. So this is a problem that everybody needs to think about if they use anything that's based on machine learning, be it large language models or some other predictive machine learning system. So what the system is learning is based on the data that you give it and the annotations on that particular data. So if that data isn't representative of the purpose that you're going to put this machine learning algorithm to, or if it is in itself biased, perhaps because it's been generated by biased humans, then the system, as we call it, the model that's generated from machine learning, will also convey that bias. And there's been a number of examples of that. I'll give you one that was an early one that I came across, where there was a company that wanted to produce a system where, when people applied for jobs to an organization, they could feed the CVs into this machine learning system, and it
Yeah.
would rank that person as to how suitable they were for this particular job. And this is a real problem for large companies, like large tech companies in the US, who might have 1,000 CVs arrive through email every single week.
Yeah.
And so what this company did was to try to build an assistant using machine learning, but what they trained it on was data from a company, and that company was a tech company which had almost exclusively employed males, like
Right.
a lot of tech companies, sadly. And one of the criteria that the humans used in order to rank the CVs was they quickly looked down to see whether the person who was applying had a gap in their CV. Now, I've sat on lots of interview panels, and I know that some people do that, because if there's a gap,
Right.
you wonder, well, what was the person doing in this
Yeah.
time? And the feeling in this company was that maybe they were struggling to get a job, and that was because they didn't have particular skills, or the references they ended up getting
Yeah.
weren't good. So they had a long period of job hunting. So they used this, trained the model, and then they used this model to rank CVs for companies where there was females as well as males applying.
Yeah.
So females who'd taken a break to have and raise kids or for caring responsibilities were discriminated
Yeah.
against by this
Right.
algorithm, which was entirely trained on males. And you
Right.
could also argue, is it fair even on males to look at gaps in the CV and to use that to
Yeah.
deprioritize people? But that's an example where the data which is being used to train the model has an inherent bias in it, in this case against females who had career breaks, and therefore that data should never have been used to generate this
Yeah.
model.
On the provision of data to train models, my wife's a commercial artist, and she has a lot of her work shown on her website and websites of clients and things like that. And one of the questions is, are the generative AI tools that are learning about what images should look like, are they using her images? And also, I've talked to some media companies that have vast back catalogues of excellently written journalistic content, and they're
Yes.
quite annoyed about the fact that these large, like, generative AI tools are being trained on content. I mean, what's your take on that? Should it be permission based?
Yes, I think that's very poor behaviour. I mean, at the moment, there's lots of court cases going through to see whether or not this is actually allowed, and that might mean that the companies who are ingesting this data actually either have to only do it where there's permission being given, or that they have to strike a deal with the supplier of the data. I noticed earlier this week, for example, the Financial Times had struck a deal with one of with one of these companies. I think it might be an OpenAI, to allow them to use the contents of their newspaper to ingest it and use it in their system. But I think that using people's data to train these models, particularly as it's not all that difficult for you'll have when you've looked at some of these systems which generate images, it's not actually all that difficult to put in a set of keywords, which means that you are getting out roughly the same thing that some human has spent their time and their skill and their energy producing. It's not like they're producing things from scratch. It can be heavily based on what's already out there. And I guess, in that sort of industry, it's usually when you infringe the copyright of somewhere like the Walt Disney Corporation that things start to get hairy, because they've got lawyers compared to I think it's the wrong behavior, and I feel particularly sorry for individual illustrators, individual artists whose work is being reused, who don't have a big legal department to back them up.
Yeah, yeah. Do you think that there's a risk to the marketing company that generates something using a generative AI tool that then looks like, let's say, Mickey Mouse for the sake of argument, and looks like somebody's work? Do you think that they're then at risk? I mean, where do you think
Yeah.
the line is being drawn?
Yes, so I'm not a lawyer, but I would have thought the defence that says, "Oh, it's nothing to do with us, Gov. It was just produced by this generative AI tool we happen to be using, and therefore you should sue them instead of us." I'm not sure how well that would go down in a court of law. So I think that this is again, I've talked about my feeling that these large language models and generative AI systems, which are generating text or images, that really they're a starter for 10 for experts. So I would suggest that, if people in marketing wanted to use them, they use them to come up with ideas, maybe to take text they've already produced and to see whether it produces a better version of it or summarize it or whatever.
Yeah.
But they need to have that critical eye, which people in your industry will already have, to make sure that, when you come up with a new name for some product or some company, I'm sure you have methods where you go and check that you haven't infringed anybody's copyright, and people still very much need to do that.
Indeed. Yeah. And without having, like, focusing on the negative, just one more thing in terms of the ingestment of data. How should people think about actually giving something like ChatGPT 3 like a set of proprietary company information? So, for example, let's just say, for the sake of argument, they want to rewrite a report about a company invention, because they need to present it to the board. They've been working in R&D. Should they put that into Chat GPT and get them to rewrite it, or what? Who then owns what they've put in?
Yeah, so that's a really good point, and we come across in the National Innovation Centre for Data, working with a lot of companies who are using large language models, working with us on that. And this is one of their main concerns, and it is often triggered by, they suddenly realize that an employee or a set of employees are putting either information about their clients, so customer identifiable information, or perhaps information which are considered to be IP, as their own IP, as you suggested, into these systems. And they haven't gone and had a look at the small print, which evolves over time. But it's certainly true that for some of these large language models, the small print will say that anything that you put in as a prompt, or any images that you upload, could be used in the future to train these models. Right. And given the way that large language models might work, so let's just take an example. I came across somebody at an American university who was using a large language model in order to write references for students. So they basically give it the name of the student, they told it what grades the student had got, and then they said, please, can you write a reference? And it produced a reference. It saved them an hour every time they had to do it.
Yeah.
And then they would send that reference off to the company that requested. But the data in that reference, all the grades, all the information about the person's opinion of that student, their name and so on, had gone off and could well be accessible in a future version of ChatGPT 3. So in the same way you could ask ChatGPT 3, or I should be careful about saying ChatGPT 3. That's just one example.
One example. Any of the big language models.
The different ones have different small print, but it could appear in the next version of one of these systems. You could type your own name in, or the name of a friend, and you could see what the reference was that had been sent sent off. So there's two things that companies can do about this. So one is that the providers of these tools now often give you the capability of having effectively a private version of the system, where they guarantee that any information you put up there, be it images or text, will not be used for training in the future. So that's one way to do it. But where it's sensitive, and we work with some clients which have very sensitive information, then what we will do is there are versions of these tools which you can deploy on your own service or on your own private cloud. And so we will do that for these organizations, so they can guarantee that none of the data that they use about their IP or about GDPR, about their customers or their workforce, will ever be used in the future training of these models.
Okay, so really, if you want to be putting proprietary information, IP or personal data points into a tool, you either need to make sure that tool is one which says, and what you put in won't be used in future. It goes into your, Tim Butler's bucket, if you like, and nobody but Tim Butler can do it. Or you put it through even more robust sort of data security. You have it on your own private cloud or private servers.
That's exactly it, Tim.
Wow. Okay. Interesting. So, what are the kind of the other pitfalls that people should be aware of when embracing AI? Because there really is a big push at the moment commercially for people and marketeers, especially, to embrace AI. What else should they look out for?
Yeah. Well, I think there's some good things that you can use it for, but every time you use it, you need to think about what the risks are of particular ways of using it. That's true whether you're using machine learning. There's lots of good examples of using machine learning, for example, to produce more personalized marketing material. So I can give you an example from some projects that we worked on with a number of companies, financial companies, but also e-commerce companies. So what they wanted to do was to understand which of their clients were likely to leave the organization, to leave as a customer. And the idea was, if you could predict that as early as possible, then you could intervene. You could offer them a better deal. You could phone them up if they had a lot of money in your bank. But you could do something about it rather than just wait until they left. And so what you would do for that would be we feed in lots of information that the organization, let's say it's a building society, that the building society has about the customer and their interactions. And then we build a machine learning model and we use that to make predictions. and that works really well, and it's helping to retain customers for some large organisations. But you have to, if we come back to the training material, so the pattern of interactions of somebody for one particular bank in one particular company may be very different to that of somebody in a different country, where culturally they interact in a different way, and we see that with people who try to take models, for example. Well, if you imagine you've got an e-commerce site,
Yeah.
and you're trying to make predictions based on the profile of a person as to what they might be interested in in buying. So again, you build a machine learning model, you feed in there everything you know about them, their age, their interests, what they bought in the past, and so you build this on data from an American e-commerce site, or the American bit if you're an e-commerce site, and then you deploy it somewhere else, like in India, for example, and it's trying to encourage some Indian kid to buy a gridiron football rather than a cricket bat, so because the thing it's been trained on isn't so relevant to the type of customers that it's being used for now. So you always need to think about whether the data that you're using to train these models is relevant for the deployment that you have of that particular model. And you need to keep regularly asking yourself questions, because as you know, in marketing, people's behavior changes over time. So whole demographics, people in particular demographics, they change what they're interested in as well as new things come along. So a model that you built, which might have been successful 2 years ago, might be completely out of date. So you need to keep refreshing the model based on new data.
So with that in mind, looking to the future, what do you see as the future for AI?
Yes, well, I think it's useful to look back at history. So this is the third AI boom in the last 70 years, and the previous two ended in what were called AI winters, because customers of AI products found that they weren't giving them value. There was no value to their business from them, and as a result, the producers of these technologies stopped investing in them. Researchers in universities moved on to other things. So I think what you have to look at is where these tools are giving business value, and our experience. So in the National Innovation Centre for Data, we've done about 100 projects over the last 4.5 years with companies of different sizes across all sectors. And I would say that in 80% of those cases, we've built with them a solution that involves machine learning. And it's made a real difference to them. And they've earned revenue from new services, or they've improved their productivity, or it's given them new insights which allow the senior management to make much better decisions. So I think machine learning is here to stay. It really is making a difference. I think large language models is another interesting question. That sort of the hallucination effect, which we talked about earlier, is really inherent in their design. And a lot of people, including me, can't see how you could ever design that out. I think that it just wouldn't work unless you designed out that randomness. And therefore, I think that large language models will have to be restricted to assisting humans. And that's that could be a good role for them. But I do not think that we will be able to use them autonomously to replace chatbots, or to automatically generate material, or to automatically answer emails, because the risks are just too high that they will do something which damages the reputation or causes financial damage to the organization. And there's been lots of examples of that.
I've certainly heard of one from a certain parcel company that there were screenshots floating around of their chatbot that was large language model powered. You could get it to say quite bad things about its own company effectively by the prompts that you put in.
Yes.
And I suppose that's, if we look outside of the technology and marketing and look at wider society, I've been to some events where people have talked about AI being maybe 25% good and 75% bad. I know it's not your specific remit, but as somebody who spends so much time in the AI machine learning world, what's your take on the effect on society of this technology as it goes forward?
Yeah. So we're always looking to do projects with companies or the public sector which have some benefit to society, and sometimes that means, for example, working with the NHS on new sorts of products and services. Sometimes it means working with medical researchers who are coming up with new ways in which to understand the condition of a disease that somebody has, or some other illness, and try to make the identification of that disease and the way in which it's treated much more effective. So those are, there is all of that going on. I think I would say that if we can work with companies so that it can become more profitable, so they can generate new profitable products and services, then that is also a benefit to society. We need that wealth generation in order for society to function, including the National Health Service. So there is that. I think the danger is where people just have this idea of the magic AI fairy dust. You can sprinkle it on any problem without really understanding it. And then you get systems which might have bias in them, as we've said, perhaps making decisions which affect people's lives. There's examples in the States about making decisions about the sentence that somebody should have for committing a crime,
Yeah.
making decisions about who should get welfare and who shouldn't get welfare. And then I think that's really the dangerous end of machine learning and AI, because a lot of these systems are deployed by people who haven't done the due diligence and ask the questions about whether the data that they're using is biased. They don't make sure that it's kept up to date so that it continues to produce sensible outputs. And really, they're often just in it to make money quickly, and they don't consider the ethics of what they are doing. So with everything in AI, be it large language models or machine learning, I think it's having expert humans who really kick the tires, ask the right questions, understand the data that it's being used for, and unpack the challenges of what happens if we deploy this in the wild, both the challenges to their organization, but the challenges to society.
So I suppose bringing that back to like marketing leadership, really, that's a microcosm within their own organizations. These marketing leaders need to be questioning the people on a individual level as well as a strategic and process led level. They need to be asking the questions of how are you using it, why are you using it, and do you understand where it's come from? Would that be fair?
Yeah, that's exactly it. So, for example, in our National Innovation Centre for Data, because we do so many projects, we have a fairly formal way of starting off with some initial discussions with a company that might be interested in working with us, teasing out what the business challenge or opportunity is, and then formulating a project. But when we do that, part of the process is to go through a process of unpacking what the ethical issues are with it, and the reputational damage issues and the financial damage issues to the organization. And we do that as part of every single project that we go through. And I think all companies which are adopting these sorts of technologies should have that as part of their standard processes.
Okay. That's really interesting, and that's probably a good place to wrap it up, because I think that's something that people should keep in mind, having listened to this and what's been, for me, certainly really, really interesting. I'm sure the other people listening and watching have found it really interesting. In terms of you talked about your work at the National Centre, how might people get in touch with you, whether it's work there or just connecting with you? How could they do that?
Well, if they go on the web and go to a search engine and search for the National Innovation Centre for Data, we've got a website. It's got my contact details, but also it's got lots of case studies from lots of different sectors and lots of different organisations. So people might find it interesting to have a look at companies that might be similar to theirs and see what they're doing and how they're using AI, machine learning, large language models in some cases in order to drive forward their business.
Okay. Oh, and I'll include that. I'll make sure that goes on the show notes for for these episodes on the different platforms.
Thanks,
So
Tim.
yeah, I mean, well, thank you, Professor Watson. I mean, I found it fascinating, and I'm sure the people that have been listening have found it fascinating too.
That's good. Well, it's been a pleasure to talk to you, Tim.
Pleasure to talk to you, and thank you to all those people watching and listening, whichever platform you choose to consume this content on. And you can tell this wasn't AI generated. We are two real humans today. So let's hope you like and hit that notification bell and subscribe wherever you get your content from. And thank you very much for your time and attention. We look forward to having you again on another Digital Marketing Answered episode.